Refraction of light at plane surfaces. This glass contains water and this is the surface of water. When light falls on the surface of water, what happens? How does it goes? Since water is a transparent medium through which light can pass through, how water travels, how light travels in water, we are going to study. How light travels at plane surfaces. After meeting a plane surface, how it travels, we are going to study. Refraction of light at plane surfaces. This is a plane surface. Water is now a plane surface. This part of water is a plane surface. When light incidents on this surface, how it's going to travel, what is going to happen, how the light is going to travel. That's what we are going to study now. Refraction of light at plane surfaces. This is a plane surface where the lower portion is water and the topper portion is air. This is air, this is water. We are to be reminded that water is a liquid where molecules are quite closer compared to air. Air has molecules which are quite far from each other. When a ray of light is incident on the surface of the water, till here the light comes with the same velocity. As long as it travels in air, it travels with same velocity. After it reaching the surface of the water, the velocity of the light changes. It's like when more people are there present on the low road, when we travel, we have to slow down and go. Since the same thing is happening here, as long as molecules are far, light travel with greater velocity and reach this surface. And after reaching the surface, it has to slow down because the water is having molecules that are quite closer to each other. This light ray actually is supposed to travel in this direction and it is supposed to go. But it will not go in that direction because the molecules here are quite close to each other. At this point where air and water are being separated, that point is called point of incidency. The point at which the light ray incident on the surface of the water, that point is called point of incidency. At that point we are going to draw a perpendicular line. Perpendicular line we are going to draw. That line is perpendicular to the surface of water. That line is perpendicular to the surface of water. That line is called normal. A line drawn perpendicular to the surface of water is called normal. The angle between the incident ray and the normal is called angle of incidency. And now, till here light travels with same velocity. Now the velocity of the light is going to change when it's going to enter into the water. Now it will bend. Its velocity changes, its direction changes, velocity changes. The velocity of the light changes, the velocity of the light decreases, or the velocity of the light changes when it goes from one medium to another medium. This is refracted ray. The ray which has bent in the second medium is refracted ray. The angle between the normal and the refracted ray is angle of refraction. Now if you see, this is in the second medium, this is in the first medium. This is incident ray, this is refracted ray. This is refracted ray, this is incident ray. Now here, towards the normal means below the dotted lines. Actual path of the light is this, below the dotted line is towards the normal. It bended towards the normal when it traveled from rarer medium to denser medium. Air is a rarer medium, water is a denser medium. Again if you see, if suppose, if this is the surface of, if this is the surface separating two mediums and the topper surface is water, this surface is water now. This is water, this is denser medium. This is air, rarer medium. When a ray of light travels in water and reaches this point, You can consider it that here also. When a ray of light reaches the lower, this point is separating the two mediums. That point is called point of incidency, and we have to draw a normal, a perpendicular line through the surface of the water. Actually, this ray is supposed to go like this, in these dotted lines. But now, when it goes from denser medium to rarer medium, this is denser medium. This is rarer medium. This is denser medium. This is rarer medium. When this ray is supposed to go in this dotted line, but it will bend towards the normal, means towards the below the dotted lines, towards the normal. Away from the normal means above the dotted line we have to draw. It will bend like that. Any ray, for that matter, if it is traveling from denser medium to rarer medium, it will bend away from the normal. Away from the normal means above the dotted lines. Towards the normal means below the dotted lines. The first point that we need to understand is any ray traveling from rarer medium to denser medium, rarer to denser medium, it bends away from the normal. First point, this is very important. Any ray, if it is traveling from rarer medium to denser medium, it will bend towards the normal. It will bend towards the normal, sorry. It will bend towards the normal. Towards the normal. Now here, any ray, if it is going from denser medium to rarer medium, it will bend away from the normal. That's what we need to understand. And second point that we need to understand is any ray traveling from denser to rarer medium, it bends away from the normal. And the third thing is, if this is the surface of the water, and again if this is water, lower portion is water, and if any ray incident, this is normal is perpendicular line, as we all know, normal is a perpendicular line. If any ray incidents on this normal, along the normal, if a ray is incident along the normal, this will not bend. If these 3 points, if you know, it is very clear. You can draw all ray diagrams through refraction at plane surfaces. Any ray, the third point that you need to remember is, any ray traveling along the normal will not bend. Here the angle of incidency is I. Here the angle of refraction is R. Here the angle of incidency is 0. There is no angle between this is normal, this is incident ray. The angle of refraction here is also 0. These are 3 very important points that we need to understand. Refraction of light at plane surfaces. If this is a plane surface, the above is air, and if the below is glass, if a ray of light is incident on this surface, as light travels in straight line, at this point this light ray is supposed to go in this straight line like this. But at this point where the light ray is meeting the surface of a glass, it will change its velocity. Because here in glass the molecules are quite close to each other. In air the molecules are quite far from each other. Therefore the velocity of the light changes. The velocity of the light changes. At this point we are going to draw a normal. This point is called point of incidency. The point at which an incident ray is met on the surface. At that point we will draw a normal. Normal is a perpendicular line drawn to a surface, and this ray is supposed to go in this direction, but it will bend and go because the molecules are closer in glass and the velocity of the light changes. This is the angle of incidency. This is the angle of refraction. If you see, this incident ray, normal and refracted ray lies on the same plane. This is the first law of refraction. Incident ray, refracted ray, and the normal lies on same plane. This is the first law of refraction. The second one is the ratio of sine angle of incidency to sine angle of incidency to sine angle of refraction is a constant. That is, sine I by sine R is equal to a constant. This constant is here is called refractive index. Refractive index of the medium. This refractive index can be defined as the velocity of the ratio of velocity of light in first medium to velocity of light in second medium. If the first medium is air and the second medium is glass, we write it like this. If the first medium is air and the second medium is glass, we write it like this. That is, well, light is traveling from air to glass, and the refractive index of glass is velocity of light in air divided by the velocity of light in glass. Here refractive index is nothing but ratio of velocity of light in first medium to velocity of light in second medium. This is the formula for refractive index.